We're looking at the concept of intervals as a subset of R. The word interval, what does it mean? In general, it means between. When it comes to watching a movie, we have intervals, that is a break that is between the first half and the second half, right? So it is between things. But in this case, when we talk about intervals in this chapter and the future chapters, we're talking about subset of real numbers, not natural numbers, real numbers. So all the things that we're going to talk about will be set of real numbers. So interval as a definition or idea is the following. All the real numbers between two given numbers. The interval of 2 to 4 includes numbers like 2.00000001 to 3.9999. Of course, this is not the closest, this is not the farthest. We can have a lot of numbers before this and we can have a lot of numbers after this. So basically it includes all the numbers, right? But the question is, will it include 2 and 4? That depends. Depends on what? The type of intervals we are talking about. In open interval, 2 and 4 is not included. In closed, it is included. In mixed, it depends. It's a combination of not and is. Right? So we're going to represent and understand all of this using inequalities, that is greater than, lesser than, or equal to signs. Interval notation using small brackets and square brackets, and number line using something like this, shading and not shading. Okay guys, it's quite simple. Let's look into this now. So first we'll start off with open interval. Now, what does open interval mean? The keyword here is not. Okay, remember this. So for example, if I talk about numbers between 1 to 10, what does it mean? We are not going to include the number 1 and 10, but anything in between we are going to include. Right? For example, over here, I have the open interval code. So the case open interval, here we're taking user input between numbers between 1 and 10, right? And we're going to tell if they enter the number right. If they do enter the number right, they will win. If not, they will not win. So let's look into this. So the user is prompted, enter a number between 1 and 10. So we have say 9. The user won. So let's talk about 9.99999. So remember, this is set of real numbers. So this is included, not natural numbers. These are set of real numbers. Let's include 2.67658. Yes, again they won. Let's include 1. You did not win. Basically 1 and 10 are not part of the group. I'll enter 10. Again I did not win. Of course, anything other than all of these numbers, like other than 1 and 10 and in between, if we enter 12 and all, again we will not win. So point is 1 and 10 is not included in any other number. Between the numbers are included, are part of the group. Anything outside 1 and 10 and including 1 and 10 is not part of the group. Right? That is your what? Open interval. Okay. So the basic idea is not including the first and the last number, the start and the end number. That's more precise, to be honest. Start and end number. Okay, does it make sense? Right? So how do you represent it mathematically using inequalities and all of that? So it's basically, so we have number n between 1 and 10. Of course, if you want to represent this as a set builder form, you will just do this. Say a set A is made up of n elements of n, such that n is between this. The same thing, if I want to represent it in a bit easier manner, I have one more notation called as interval notation. All I have to do is do this. Okay, using flower brackets, not flower brackets, sorry, small brackets. If I do this, it talks about open interval. So both the ends we have 1 and 10 are not included, any other number between them are included. Using number line, we'll just do this. You have a big circle which is not shaded. You just write 1 and 10 over there. So any number in between them is included and 1 and 10 is not included. Okay, moving on, we have closed interval. So you guys have a good grip on the concept now by now. So what does it mean? Do include. So we have, what is the keyword? I forgot the keyword. Not over here is S or S. Not include is included. Okay, not included is included. Yeah, we'll go with the keyword yes. Again, whatever makes sense to you guys, you can use that to be the keyword. So example is, say we have number between 1 and 10 including that. Okay, so basically, let me write it in a different manner. Numbers between 1 and 10 including, again this is an example, 1 and 10. So the basic idea is you include it. Okay, so basically it is over here. How did we put it across? Not included. So here it is included. So do include the start and numbers and all the numbers between them and all numbers between them. Okay, so how do you represent it? Using inequalities, we can represent it in this manner. So we have n, right? So let's use that. See, I've done that over here, and let me run this. So enter number between or including 1 and 10. So I'll include 1.00001. So I won. If I happen to press 1, what will happen? Yes, again I will win. Of course, any other number lesser than or greater than all of those numbers. So like 0, well, I lost, right? And if I enter 10, what happens? Yes, it is included, and so we will win. Okay, it's that simple. So if I have to build or represent this for a set builder form, like set A will include numbers between this. I'll do this. We have used all of this. Now we are just giving the name. Using interval notation, how do you put it across? So we put it across in this manner. That's it. So there it was what? Small brackets. Here it is square brackets. That's the difference. Please have a look at this. This is small and this is square. This is small. Right? Of course, this you should not be writing it over here. Using number line, same circle, line, a circle, you just have to shade it. So 1 and 10 are part of the group. Now, mixed. So mixed, you can have many variations. So the one which I have included as part of this answer or part of this code is, yeah, including 1 but not including 10. So for example, we'll include number 1 and numbers between 1 and 10 but not 10. Okay, so the basic idea is this. So we will have, I think I'll execute it over here. So enter a number between 1 and 10 or the number 1. So basically if I enter 6, I will win. If I enter the number 10, what happens? I will not win. If I happen to enter 0.39 or 99999 also, I'll not win, right? So you got the gist, right? If I happen to enter 1, then I will win, but not 10. So the basic idea is include at one end, but not at the other end. That's your mixed. So it can be, we can include at any end actually. Include at one end and not at the other. So how do you represent this inequality? Using inequality, I can do this. So for this example, it was something like this. So if I have to put it across as a set builder form, set A is made up of n such that n is this. Now the tricky part. How do you put it across as a notation? What do you think? Which is correct? Which is correct? Yes, the second one is correct. Reason being, the square brackets talks about being included, small brackets tells that this number is excluded. So using number line, what should I do? Again, circles. So where should I shade? Yes, please do tell, I can hear. Yes, most of you are right. Actually, all of you are right. We have to shade at the number 1 part. Right, guys? And so we have the following concept. So you guys can copy your notes from here, or I'll show you guys one more set of notes. You can copy it from there. Yeah, so this can be your second set of notes. If you guys want to read from here and have a look, please do so.